All right, so we have to talk about one little twist that happens with radical functions. This happens with some other functions as well, but this is the first time that we're seeing it happen. So there's something called an extraneous solution. And so what an extraneous solution is a number that when you go through the process of solving, you get to the end, you did everything correctly, but when you go back and you plug that value into the function, it doesn't actually work, which means it's not a solution. So it's a solution. It's a value that comes out of solving the problem that is not actually a solution. Okay, so just to remind you, if you take a look, here's a problem that we worked on in some of the last videos on solving radical functions, or solving radical equations. And our job here is to isolate the radical, which in this case is the 3c, by getting rid of anything on that side that's on the outside. So this 8's got to go. Okay, so I'm going to subtract the 8 away. Okay, and I'm going to say this says the square root of 3c is equal to, when I do 2 minus 8, I get negative 6. Okay, so now I have to square both sides. Right, so I'm going to square, in this case, the 3c, the square root of 3c, and I'm also going to square negative 6. So when I do this, I get that 3c is equal to, well, that looks like 36. Okay, when I divide both sides by 3 to finish this one off, it looks like c is equal to 12. Okay, so if I go back to my original problem and I plug in the fact that c is equal to 12, okay, which again, you take a look at all the steps that we did everything correctly. Okay, when I plug that in, let's find out what happens. It says the square root of 3 times 12, okay, plus 8 should be equal to 2. Okay, and so when I do the 3 times 12, well, that's 36. This is really the square root of 36 plus 8 is equal to 2. Well, the square root of 36 is 6. And this says 6 plus 8 is equal to 2. And that's obviously not correct. 6 plus 8 is equal to 14, right? That's not 2. So this doesn't work. So I'd say 12, which is the answer that we got out of this problem, is actually an extraneous solution. It looks like a solution, but it doesn't actually give us the correct answer that we need. It doesn't work when we plug it back in. Okay, so in bold letters here, I say you always have to check your answers to radical equations, because it's possible that you did everything right and you're saying, hey, look, I got it, 12 is a solution, but you see we just plugged 12 back in and it didn't work. It's not a solution. Okay, so let me just show you a couple other examples of this happening and a couple other solving radicals problems as we go. Okay, so we're just going to, as we do these problems, be sure that when we're solving, we're checking our solutions for any extraneous solutions. Okay? So in this second problem, I run into something a little bit different. When I try to square away the square root symbol on the right, because this is isolated, so I can square this. Okay? I'm also going to square a variable, which is the first time we're doing that. So when I simplify this, it looks like a squared equals, radical symbol's gone now, a plus 12. Okay? So this one is actually a quadratic, right? I got a squared in my problem now. So to solve this, I have to get everything to the same side, try to set it equal to 0, so I can either factor or I can use the quadratic formula if factoring doesn't work. So I'm going to subtract this a over, and I'm also going to subtract this 12 over, and they're going to show up on the other side as minus a and minus 12. So my quadratic that I'm going to try to factor is a squared minus a minus 12 equals 0. So if you remember what we said for factoring, we had to find numbers that multiplied to negative 12 and added up to, in this case, the negative 1 that's in the middle. And those numbers are going to be negative 4 and positive 3. So I'm going to say this is really factors into a minus 4 and a plus 3, and that equals 0. So we said set each of those equal to 0. A minus 4 equals 0, or a plus 3 equals 0. And I get two answers. I get a positive 4. That's a solution, okay, and I get a negative 3, and that's a solution, okay. So let's leave those. So again, we got to check, and we got to make sure these are actually going to work. So if I went back up here and I plugged in the 4, this would say 4 equals the square root of 4 plus 12. Well, that's 4 plus 12, 16. The square root of 16, okay, is equal to 4. That's good. That's right. So this is a good answer. Okay, so let's try the negative 3 and see what happens with that one. So when I get rid of this here, so we can do it again. Okay, so I'm going to do the same thing, and I'm going to plug in the negative 3. So now this says negative 3 equals the square root of, well, negative 3 plus 12. Negative 3 plus 12 is 9. the square root of 9 is 3, not negative 3. All right, so we're going to say in this case, negative 3 is not a solution. Okay, and you might be saying, well, isn't the square root of 9 3 and negative 3? Right? When we're dealing with radicals that we're not actually performing the operation, right? We're not introducing the square root into the function. It's already there. When that happens, we always assume that this is referring to the positive square root. It's called the principal square root. Okay? If they wanted us to have to say that the square root of 9 was negative 3, what they would actually do is they'd put a little negative symbol out here to let us know to take the square root and then give us the negative version. So since that's not present in this problem, we're not going to assume that they want the negative 3. This is the principal square root, which is positive 3. Okay? So in this case, negative 3 is not a solution because this says the square root of 9 is 3, and on the other side I had a negative 3, and that doesn't work. Okay? So we have an extraneous solution again. Okay? Last problem, and this one does not have an extraneous solution when we check it, but something kind of strange happens here. We actually have a radical on both sides. This is the first time we're seeing this. All right, so I want to get rid of both of these radicals. There's nothing floating around on the outside of either of them, which is good. So I can actually square both of them right away. Right? And that's just going to make the radical go away on both sides. So I'm going to say 5y minus 11 is equal to y plus 5. Okay? And I can solve this. Right? I'm going to subtract y on both sides, get the y's together. Okay? That means that 4y minus 11 equals 5. Okay? I'm going to add the 11 on both sides. And that means that 4y is 16. Okay? And that means when I divide by 4 on both sides, that y is equal to 4. Okay? And again, let's just check it really quick. We need to get in the habit of checking all of our solutions. If I plug in a 4 here, this says 20 minus 11. Well, that's the square root of 9. Okay? And on the right, when I have 4 plus 5, which is also the square root of 9. So both of these are giving me 3. So this is actually a solution that I checked it. It did give me a correct statement when I plugged it back in, so this is a good solution.